Coming back to these time to failure data, we have decided based on a histogram and a box plot, at least based on what they look like, that these data don't follow a normal distribution. But sometimes it can be really hard to judge a histogram or a box plot, like how skewed is skewed enough for them to be not normally distributed. There is a way to judge the normality of data by using a graph called the probability plot. Now, this is not the same as the probability distribution plot. A probability plot is an XY plot, and if the data follow the distribution you ask for, the data will follow along a more or less straight line. So let's have a look at this. I'm going to use my time to failure data. I'm using one single set of data. I say OK. I pick the data that I want to check the normality on, and I'm using my raw time to failure data. And note here that there's a button here for distribution. And I just want to know, do these data follow a normal distribution or not? You don't need to indicate your mean or standard deviation. Unitab will do its thing. And here's my probability plot. And notice up here it says it's checking to see if they're normal. Now, if they were normal, the data, which are all these blue dots, would plot along this middle red line, and these outer red bands are referred to as confidence intervals. So if they were normal, I'd expect all my data to fall somewhere between these outer red bands, and if they were completely, totally normal, they would follow along this straight line. So from a visual point of view, well, they're not normal, because most of these data fall outside this band area here. But in addition to that, because sometimes that can be hard to tell as well, Minitab will give us a p-value. And as your notes say, if the p-value is a number less than 0.05, you can be 95% confident that the data don't follow a normal distribution. Okay, and since our p-value is less than 0.005, which is certainly less than 0.05, we are, in actual fact, more than 99.5% certain that these data don't follow a normal distribution. So these p-values give us something that's a little bit more definitive for an answer. Now, at the same time, I could check to see whether the data that I've logged actually follow a normal distribution. So coming back into my last dialog box I had open, rather than choosing my raw data, which I now know from my probability plot don't follow a normal distribution, let's check if the log data do. So we've already logged the data ourselves. We go in, and now we want to find out whether they follow a normal distribution. I say OK to that. And now notice that the log data points all fit inside these outer red bands, and most of the points fall along the middle red line. And I'm getting a p-value of 0.921, which is certainly a lot larger than 0.05. So what would I conclude here? I'd conclude that by logging the data, I've actually made them follow a normal distribution. And another thing I could have done, by the way, is take my raw data again, and rather than physically going in and logging them, which we did a few videos back, I could just go in and say, all right, let me try different distributions. Let's see if these data actually follow a log normal distribution. Say OK and OK. And now I get a plot pretty similar to the one I just saw, only now it's checking to see if these data follow a log normal distribution. Again, the points all fit inside the outer red bands, and my p-value is the same as what I just had. So what this is really telling me is these data are certainly more suited to a log normal distribution. And if I was to do anything else with these data, I'd want to use the log form of them and not the raw form of the numbers.